Okay, what we have here is a homemade conductivity tester. Basically all it is a light socket. And instead of the way it should be, which is there are two wires coming off the plug, they should go directly to these two terminals. But what I've done is the one wire goes straight to the terminal. The second wire, if I were to take the tape off, gets tied into this black wire here. And then this other black wire goes to the other terminal. So what we've done is we've made a gap in the circuit so that the circuit is only completed by something touching these two wires. Now you'll notice that this is not plugged in. Were it plugged in, I would have just gotten a 110 volt shock. Alright, to prove to you that it works, what I'm going to do is I'm going to plug this in. And carefully touching only the insulated part of the wire, I touch these two together. And you see that the light bulb lights up. Now, what I have in front of you here is I have a bunch of different solutions. The first one is just distilled water. If I take the distilled water and I put it on these two prongs carefully without touching them with my hands, will it light up? Take a moment, pause the video, and think about whether water should make this bulb light up. Okay, so if we try this, will the water make the bulb light up? No, it doesn't. Now that seems a little surprising because we're always told, not go swimming in electrical storms and all that sort of silliness. But the fact is, this isn't swimming pool water or lake water. This is distilled water. So it has very, very, very few ions in it. Not none, we'll talk about that later, but very, very few. Now, the other things we have, on this side we have sodium hydroxide, 1 molar, and ammonium hydroxide, 1 molar. Same concentration of both. And on this side, we have 1 molar hydrochloric acid and 1 molar acetic acid. Same concentration of both. These are bases, these are acids. Now, what I'm going to do is I'm going to take each in turn and I'm going to see if it conducts electricity. So if I take my 1 molar sodium hydroxide, it really conducts electricity quite well. Now, so that I don't contaminate the experiment, I'm going to rinse these off between tries. Now, sodium hydroxide, 1 molar, lights it up. 1 molar ammonium hydroxide, will it light it up? What do you think? Now notice there's a difference. Notice that here, with the sodium hydroxide, it's very, very bright compared to the ammonium hydroxide. Wonder why that is. Okay, remember we need ions to conduct electricity. Alright, let's try the same thing. Hydrochloric acid lights it up. About the same as the sodium hydroxide did. How about acetic acid? It's an acid. It's the same concentration as the hydrochloric. Let's try it. Well, that's strange. It doesn't light it up nearly as much as the hydrochloric did. Wonder why. So that's something I want you to think about. These two, both the same concentration. One's ammonium hydroxide, one's sodium hydroxide. This makes it really bright, this doesn't. Hydrochloric acid, acetic acid. This makes it really bright, this doesn't. So what's the difference?